Welcome back to From the Ground Up, a podcast from the University of Chicago Public Policy Podcasts, where we dive into the process that turns minerals in the ground all across the world into green technology like solar panels and EV batteries. I'm Quinn Pennington, and I'm here with my friends Rand.
Hey.
Logan.
What's up?
And Christian.
Howdy.
Last week, we did a deep dive on what happens before mining begins. Today, we're going to look at the life cycle of mines, from designing a mine to closure and reclamation. Logan, let's take it from the top. How are mines designed?
Yeah, thanks for that, Quinn. So, the design of a mine depends on a variety of factors, including the type of resource being extracted, the location of the mine, and the available technology and resources. There are several different mining methods, each with its own inputs, outputs, and environmental impacts. Some common methods include open pit mining, underground mining, mountaintop removal mining, whereas open pit mining is going to involve removing large amounts of rock and earth to access the resource in question and can have significant impacts on soil, water, and air quality. Underground mining involves tunneling deep into the earth to access the resource and can also have environmental impacts such as soil subsidence and water pollution. Mountaintop removal mining is more so of a controversial method that involves removing the top of a mountain, as it says on the tin, to access the resource and can have significant impacts on water quality and biodiversity. Companies may use a combination of different mining methods depending on the specific resource being extracted and the characteristic of the deposit. The design of a mine also includes plans for managing and minimizing environmental impacts, such as reclamation plans for restoring the land after mining is complete.
Let's dive deeper into that. Christian, how do mining companies choose between different mine types?
When designing a mine, mining engineers design the mine around the ore body, from the ground up, like the title of this podcast. They'll start by looking at the environment. Each ore body and the rock that hosts it is unique with varying characteristics from the terrain, the rock type, geological and environmental considerations, etc. Companies will also consider any existing infrastructure to support the mine, which can be different depending on how rural or developed the area is. Think about, for example, rural areas in poor countries where there may not be roads that can support heavy machinery versus a rural area of the United States where there may already be access to interstates and other infrastructure. All of these factors go into the feasibility study. The study considers all costs associated with the project as well as estimated returns in order to inform whether to proceed with mining.
Rand, tell us a little bit more about how feasibility is assessed and how that can be different in different international contexts. What kind of other impacts do these differences have at an international level?
Well, there's no international standard for mine feasibility studies. The criteria may vary wildly based on practices from country to country. And as we discussed, an important goal of feasibility studies is to demonstrate that a proposed mining project has the potential to be profitable in order to secure investment funding from financial institutions. Many entities, including over 130 banks and other financial institutions across the globe, make use of the Equator Principles, which are based on the World Bank's performance standards on environmental and social sustainability. However, not all banks abide by these principles. Most notably, many large Chinese financial institutions are either not signatories or are in the early stages of adoption. And these different standards can play into geopolitical tensions. China's well-known Belt and Road Initiative launched a mining industry development fund in 2015 with the goal of raising 10 billion yuan, according to the International Energy Association. For example, the U.S. withdrawal from Afghanistan and subsequent sanctions regime has led analysts, including the Atlantic Council's Amin Mohseni Charglo and Niels Graham, to predict that a cash-desperate Taliban regime might open up Afghanistan's rich deposits of lithium, copper, and iron to greater investment from and extraction by China and other nations less friendly to U.S. priorities and less stringent with anti-corruption and environmental concerns in mining projects. See, that's where the different standards come in. Lithium is extremely important for the green energy transition as it's a key component of electric car batteries, so lithium extraction is an emerging area of geopolitical competition and tension.
Okay, so we've talked about all of the basic features of the environment, like the mineral deposit and the built environment near a site. What else do companies have to think about when designing a mine?
Companies have to think about the equipment used in the mine that is integral to the design of the mine. For example, tunnels, routes, and shafts bored in the mine have to be able to support the weight and size of the equipment that you'll be using. It's critical to an engineer that those throughways are designed well enough that they'll be structurally sound to support the equipment moving around and vibrating as the rock wears down from use and natural elements. If you don't, then eventually you're going to have a structural failure, like a landslide or a collapse. Additionally, the mine must maintain its structural integrity over time, as a compromise will arise. A good design helps mines run efficiently and maximize profits. Another example is mining equipment, which uses diesel fuel that emits fumes where operators might be exposed. Because of the exposure, a mining engineer considers the type of ventilation necessary to ensure that the operator has adequate levels of oxygen to work safely.
But there's also newer mining equipment where people aren't exposed, right? Like some vehicles might be airtight so that people who are inside aren't exposed to the air in the mine, and then there's even equipment where you don't have anyone inside at all. They're like these giant robot trucks that run autonomously like a Tesla, or they're operated remotely like a drone, right?
Yes, let me be clear. There are large Caterpillar dump trucks, those haul trucks that we used to play with as kids, or large excavators or shovels or loaders that are used in the mining industry that are completely automated. However, these autonomous pieces of equipment can be remote controlled by an operator, whether at the surface or in the cab.
What are the implications of using these new technologies?
If you use this type of equipment, you might be able to save capital on your ventilation system. Instead, you might want to prioritize an adequate Wi-Fi network that can connect autonomous or digital equipment underground that relies on the network to operate. You also want to prioritize cybersecurity to make sure that the network is well protected.
Whoa, so for cybersecurity, the idea is that you need to protect mines against hacking.
Yes. This past February, I attended the annual Society for Mining, Metallurgy, and Exploration conference. Cybersecurity was discussed at length as a priority in implementing automated equipment as the mining industry becomes more digitally dependent and vulnerable to cyber attacks. 2022 was a record year for cybersecurity attacks on the mining industry by hackers. The largest target was Copper Mountain.
That's super fascinating. I hope that we can dive a little bit deeper into that in a future episode. Okay, so we're following this story and we've reached the point where a mine has been designed. All of the decisions have been made and it's time to mine. What happens next? What kind of complications can come up?
Sometimes complications are minimal. In some cases, complications of the mining industry are just part of the job. For example, if equipment breaks down during operations, you need to get the equipment up and running in the field in real time. If the equipment is down, then the mine is losing money by not extracting ore. Or another complication is that weather impedes production. Say, a big snowstorm comes in and despite equipment being winterized, the train tracks for the mine train may be covered with ice and need to be broken because it inhibits production. If not, then you can't bring ore up to load onto haul trucks and send to the mill. Or maybe the storm was so heavy that it is difficult for haul trucks to navigate safely and therefore the roads need to be plowed and salted. These are part of the operation.
When everything goes as expected and complications are minimal, how does mining affect communities?
Yeah, thanks, Quinn. When we hear these notions of things going to plan and complications being minimal, we should always ask ourselves, according to whom? Last episode, I talked about the inequality of resources and leverage between mining companies and communities when negotiating over the placement of a mine. Once a mine kicks into gear, their operations may not reflect the wants and needs of the community, and they may pollute the air, soil, or water to an unhealthy extent, especially if there's a profit incentive in not self-regulating these issues. Even in cases where the mining company appears to be meeting their commitments and giving the community say, perhaps through one of those fancy community development agreements that we talked about last time, the impact of mining on communities can still be significant. While mining can provide job opportunities and boost the local economy, pollution doesn't necessarily disappear, and environmental harm is still a given. And just one last note, the socioeconomic impacts of mining can also be detrimental to communities. Mining often leads to the displacement of marginalized communities and can exacerbate existing social and economic inequalities. Wealth and power are still often concentrated in the hands of mining companies and their shareholders, rather than being distributed fairly to the local residents.
Christian, from the technical side, tell us a bit about when complications are more significant.
Complications may be worse, for example, if there's a tunnel collapse. If the tunnel collapses while the mine is closed, there might not be fatalities, and that's a good thing. However, the tunnel did collapse, and that needs to be reported and investigated to determine why we did not foresee the collapse. Therefore, investigators have to determine the damage and whether it's safe to begin clearing and rehabbing the tunnel in the case of an underground mine. However, if a mine collapse is more catastrophic and there are fatalities, for example, the recent landslide in China, where an estimated 50 operators were killed, In those cases, there's a full stop on production, and search and rescue scrambles to determine when and if it's safe to begin search and rescue and begin searching for survivors. Once search and rescue has completed, then an investigation will begin on the structural failures and proceedings up to the point of the accident to determine liability. In the case of some U.S. mining accidents, liability can be placed on both the mining firm and government regulators for lack of oversight. Fortunately, mine accidents have decreased over time to innovative methodologies, technologies, and increased standards are common, although they do still happen. Personally, reading those reports and transcripts of past accidents is both heartbreaking and frustrating.
Logan, you're our resident expert on environmental and community wellness. What are the implications for communities when there are these catastrophic events?
Yeah, well, the worse the incident, the worse the consequences are going to be. Exposure to hazardous substances such as heavy metals and toxic chemicals can lead to respiratory diseases, neurological disorders, and cancer. And the worse the disaster, the more people are affected. In 2015, the Mariana Dam disaster in Brazil released 60 million cubic meters of toxic sludge into nearby rivers and communities, resulting in 19 fatalities and devastating impacts on local ecosystems and communities. A bit over 3 years later, the Brumadinho Dam, owned by Vale, the same company that owned the Mariana Dam, also collapsed and released 12 million cubic meters of toxic material, and this time resulting in 270 fatalities. These incidents are considered two of the worst environmental disasters in Brazil's history, and are tragic examples of the potential human and environmental costs of mining operations when there is a lack of policy. And I think something important to highlight is that while the Mariana Dam involved significantly less immediate deaths than the Brumadinho Dam, the insidious fact of toxic catastrophes is that these can be slow killers. I mean, 60 million cubic meters of toxic sludge. I don't think the human brain can even fathom what that number even means. So, an unthinkable amount of contaminants flowing into the towns, the rivers and watershed, the soil and plants, that's going to affect the land for years and probably decades to come. And people aren't going to always be able to leave, especially indigenous and marginalized communities. Over time, that's going to lead to people in these communities living lives that are likely to be shorter or medically complicated in some way, and raising children whose lives are going to also be profoundly affected by the environment they were raised in, facing similar, if not worse, fates. Clearly, it's not enough to be laissez-faire on mines and leave them to self-regulate, because when we do, we see companies like Vale allowing environmental atrocities twice in 3 years.
How often do these kind of catastrophic incidents happen?
Mining accidents across the globe have been falling steadily for the previous several decades. In the developing world, they've fallen dramatically since 1945. They're starting from a higher baseline, and so we see a greater reduction. However, the rate of accidents and fatalities remains higher than in the developed world in many countries, including China. I use China as a contrasting example to the US a lot on here, but these trends are by no means limited to any one country. Across the globe, policymakers must consider many competing priorities when setting regulations, including energy security, economic growth, and safety for both miners and surrounding communities. Unfortunately, it looks like, under increased geopolitical pressure, policymakers across the globe might be prioritizing production or profit over safety enforcement, raising the risk of catastrophic loss of life. And in my view, this is not a good trade-off to make.
Let's move forward along the life cycle of the mine to the end of a mine's life. Most commonly, mining ends when the mine is exhausted and there's nothing left to extract. In some cases, mining might stop because it's no longer profitable or because a company is kicked out, perhaps due to armed conflict, geopolitical tensions, or community backlash. What goes into the process of closing a mine?
Sure. So mining requires a lot of water, and water is essential for various activities like processing the ore to clean it or to prevent dust from going airborne when mine operators are mining, drilling per se. If you don't, the nearby communities and operators might come into contact with the silica dust, inhaling it, leading to various chronic diseases. A little bit of background. In earlier periods of Western expansion, the United States did not use water, and the operators would inhale silica dust, creating small cuts in their lungs. These drills were dubbed the Widowmakers because the operators would die of complications due to inhaling that silica dust. Therefore, water was introduced to wet the rock when mining, drilling specifically, to prevent the dust from going airborne. Outside of the mine, roads for haul trucks are watered down for the same reason, to protect the nearby communities, which might otherwise be affected from the airborne silica dust that would result in a potential lawsuit if evidence did show that there was long-term illness due to the silica dust. However, the trade-off is now that the water is contaminated, it's unusable if not treated. So, a water treatment plant must be built. If not treated, the water remains acidic. If a person encounters a contaminated water, it could eat through their clothes and their skin. You can't drink this water either. Furthermore, water treatment facilities serve to pump water out of a closed mine that may fill up as a result of runoff. If it isn't properly maintained, then the water can build up pressure that threatens the surrounding environment. An example of this is the Gold King mine spill.
What about the social and environmental parts of closing a mine?
Well, as you can see, the implications of varied reclamation standards are critical, and they can result in severe damage that could be fatal. Another concern of proper closure is keeping the public out of abandoned mines. There are tens of thousands of closed mines throughout the U.S., specifically in the western regions where tourists and treasure hunters explore. However, if a person is trapped in one of these mine shafts in a rural location where a mine hasn't been maintained for a considerable amount of time, it could mean their death. This is a growing problem. For example, in Arizona, in 2018, 35 people were killed, 22 injured in this type of activity. What comes to mind for me is who's liable at this point? Is it the individual for knowingly entering the abandoned mine, or is it the firm who didn't adequately close the mine, even if they are still in existence?
What are tailings?
Tailings, in short, are waste rocks that are discarded into a stockpile because the ore within the rock may be too low grade or it's useless for the mine. The issue with tailings is how they're disposed of. If left to the elements, the tailings themselves present an environmental risk that could contaminate the environment and lead to erosion. Tailings from mines are often repurposed in the form of a tailings dam to pond waters that should be undergoing the process of treatment, or to shore up a pond of acid drainage from the water use in the mine.
That sounds kind of risky.
Yeah, tailings dams present inherent risk in their structural integrity, and if the dam fails, as it did in 2015 at the Mariana Dam in Brazil, then people can die. However, there are several opportunities to mitigate dams, like dry stockpiling, water filtering, recycling, repurposing the tailings, or innovative mining methods and technologies that are of low impact.
Rand, tell us a little bit about how the legal landscape has changed over time.
Well, Quinn, mine reclamation was not included in the original mining law of 1872. It took actually more than a century later, in 1977, with the Surface Mining Control and Reclamation Act, for a more comprehensive legal framework to be introduced. Now, this law requires coal operators to reclaim land they disturb. And that same year, the government also required reclamation bonds to be issued by companies so the government can complete reclamation projects if the mine operator doesn't or goes bankrupt. The federal government also introduced the Abandoned Mine Lands Program in that same year to help clean up sites that were closed before 1977. And in the present day, the Bureau of Land Management runs that.
So what's the word with reopening?
In recent years, as mineral deposits closer to the surface have been extracted and as more focus has shifted onto sustainability, many companies and mining operators are shifting their focus onto reopening abandoned or closed mines and using new technology to extract minerals that were previously unfeasible or unprofitable to mine. Some of these techniques aren't really proven yet. Becky Robbins in The Atlantic talks about a gold mining company in California that's using a technique called paste backfilling, where they inject a mix of mining waste and cement into their tunnels to reduce the amount of above-ground waste they produce. However, many of these technologies are still in the early stages of testing, and much of this mining depends to a huge degree on macroeconomic conditions. If commodity prices fluctuate, the mineral might not be profitable to mine at all, and the mine runs the risk of being abandoned again.
Logan, all of this sounds like it could be kind of dicey for communities. Can you kind of walk us through different types of afterlives that a mine can have and what that looks like for communities?
Yeah, absolutely. So the first type I would say is just the run-of-the-mill abandoned mine. After a mine is no longer in use, it can have a range of environmental and safety impacts on the surrounding community and ecosystem. Abandoned mines can pose a significant risk to public safety as they may contain hazardous materials and unstable structures, as we were talking about with the tailings earlier. Some abandoned mines have been repurposed for non-conventional uses, such as tourism or recreation. However, these uses may also pose safety risks and have potential environmental impacts. Yeah, so kind of like what Christian was saying earlier about using these abandoned mines, whether it's exploring or whatnot, abandoned mines can be dangerous and deadly despite their pretty appearance. The Colorado Division of Reclamation, Mining, and Safety advises people to stay out and alive, quote unquote, and avoid exploring abandoned mines. Many people suffer injuries or fatal accidents every year while just exploring abandoned mines, highlighting the importance of staying away from these sites.
But it's not always like that, right? Like, I've toured a mine that was, like, open to the public.
Yeah, that's definitely true. While abandoned mines can be dangerous, they can also be reclaimed and restored to a safe and stable condition through a complex and costly process. So that's probably the kind of mines that you've explored. Reclaiming abandoned mines can have a range of benefits, including improving public safety, restoring ecosystems, and creating new economic opportunities.
We've talked a lot on this podcast about how, with the need for green technology and other types of changes in technology, there's more and more of a demand for some resources that need to be mined. Does that ever come into play when we're talking about mines' afterlives?
Yeah, for sure. In some cases, mines are reopened due to increased demand for the resource, improved technology, or changes in regulations. The process of reclaiming a mine site involves restoring the land to a safe and stable condition, which again can be a costly and complex process.
This brings us to the most fun part of the podcast, takeaways. Logan, what's been swirling around in your head as we've been talking about all of this?
Yeah, I think just to rehash on what I've been talking about today, but there's really such a long way to go. We've been talking about how mining works, who's affected by mining, and some of the minimal and maximal consequences of just something as basic as leaving tailings around in a community. Responsible mining practices obviously are important, effective monitoring, but we have a world away to go for regulation to make sure that we are prioritizing safety and well-being of our communities and ecosystems.
Christian, what's your takeaway?
My takeaway from all this is perhaps the most boring thing that we've talked about on this podcast that I just ran with it in my head over and over and over is this backfilling methodology that Rand was talking about here concluding our podcast today. I think it's pretty fascinating, and I want to do a lot of research on that.
I'll go next because mine is also kind of technical, but I really want to circle back to the giant robots and the Wi-Fi and the cybersecurity. Like, when I think about mining, the image is, it's just like the Rocky Mountains and it's all wooden structures and, Pickaxes, yeah. And, listeners, I encourage you, do a little Google on these Caterpillar machines that Christian described. It is, wild. The visual is much different than I expected. And also, I don't know, I didn't realize that mining is subject to all of the same sorts of, concerns and issues that we associate with other technologically oriented logistical fields. Rand, what are you thinking about?
Well, Quinn, if you know me, I'm always thinking about ways in which international currents intersect with local concerns. Earlier last year, I remember hearing a speech by a member of the Biden administration saying that they want to increase recycling and recovery from closed mines and from mine wastes to increase domestic production of critical minerals. I think it's important to keep in mind the trade-offs that we've discussed on this episode, including miner safety versus efficiency and competition from other countries.
What does that mean? Say a little more.
Well, we saw in China in recent years, we talked about coal mining there a little bit, amid a push to increase their domestic energy self-sufficiency, we saw a huge increase in deaths and injuries for miners in that industry. And speaking as an American, we want to be very sure that even as we're trying to ramp up domestic mining and manufacturing of critical materials, minerals, and technologies, that we do it in a way that protects the health and safety of not just miners, but also surrounding communities. Although it's not as big as it used to be, my home state of Virginia historically has had a pretty large coal mining sector. And with much of the state containing some of the Appalachian Mountains and the Blue Ridge Mountains, there is always further potential for mining and development there. And I want to make sure, at least for me personally, that the beauty of my home state and the health and safety of my neighbors is respected.
I think that's a good note to end on. Thank you for joining us on From the Ground Up. If you have thoughts or questions, or if you would like to talk to us on air, drop us a line at uc3p uc3p@gmail.com. That's 3, the number, uc3p from the ground up at gmail.com. Talk to you all later.